Class, this is Miss Anderson. Sorry I can't see you all. I miss you all so much, but the show must go on because Corona don't stop no show. And I know you've had enough Fortnite in your system, so come on, let's get this work done. So the last thing we covered in class was systems of equations, and that ended on page 108. So now I need you to get your workbooks and turn to page 109. Also grab some notebook paper because I need you to take some notes. Not a lot of notes, we're gonna take a lot of notes. Okay, so title it and feel free to pause and play anytime. So title your paper, The Real Number System. Okay, so here we got the real number system. And I want you to kind of split it in half. Oops. I want you to kind of split it in half. Well, not half, but 3/4 and a quarter. And on the left side, I want you to title it, this is going to be our rational numbers. So our rational numbers are going to go on the left side. And our irrational numbers will be on the right side. Okay. So when you think about rational and irrational numbers, always try to have a level of real life in math, right? So rational people, those are the people who are, living consistently, doing the right thing. Irrational people, they probably are in jail or just doing the wrong thing, right? So think about that when you think about these numbers. And they're not consistent. You kind of don't know what they're going to do next. So rational numbers. These are numbers you already kind of know. So we're going to start off with our counting numbers, which are called our natural numbers. They are like 1, 2, 3, 4, 5, 6. So these are our natural numbers. Oops. And they're these are natural numbers. So like 1, 2, 3, 4, 5, and so forth. Who remembers what that's called? Think times up in ellipses. So pat yourself on the back if you got that right. All right, so we got our natural numbers. Then, that's also a natural number. We got our whole numbers, which is our natural numbers and 0. So we got our whole numbers, which is just our natural numbers. So it's like 0, 1, 2, 3, 4, ... right? So natural numbers are whole numbers. So then we have our famous integers. Y'all love integers. We have our integers. That's our negative numbers, 0, and whole numbers, and natural numbers, sorry. So it's -2, -1, 0, 1, 2, and so forth, and in both directions, right? Oh, and that encompasses all of those. About to run out of space. Then we have, and my handwriting's not that bad, so don't check me. I mean, it is bad, so don't check me. Then we have our then we have so all of these are rational numbers, right? So then let's think about we got our just real numbers, and we're gonna call those. Let me see, what color can I use? Orange. We can call those these just different numbers. So -1.816 is a real number. These are numbers, decimals that terminate or repeat. So this is a terminating decimal because it stops. A repeating decimal would be 2.3333. And we know we can write that with the line at the top. Another repeating number can be like 1.555. And then we can put the line over the top because it's repeating. These are our rational numbers because they either decimals that terminate or repeat. So all of these are rational. So all of this is rational, these type of numbers. And also this is a kind of a trick question. You'll see something like this. So the square root of 4, because the square root of 4 is really equal to what? 2. So that's also rational. So they'll trick you like that. Then we got our irrational numbers. These are numbers that cannot be written as a fraction. And let's add like 2/3. That's rational. And like -1/2. That's rational, for instance. And then we have our irrational. And these are numbers that cannot be written as a fractions. These are numbers like pi. Because pi is a number that goes on and on forever, right? So like, let me use my phone. And I type pi in my calculator. I got the turn thing on. And I type pi into my calculator. Where is pi? Am I blind? Oh, there's pi. So pi. You see how this long decimal? So pi is approximately 3.141592, so forth, right? And we don't know what's going to happen next, so it's irrational, right? So also numbers like square root of 2, because when I type the square root of 2 in my calculator, it's also a long decimal that does not terminate and does not repeat. So it's non-terminating and non-repeating. So that means we don't know what's going to happen. So square root of 2 is approximately 1.414213 and so forth, right? We don't know what's going to happen. Also numbers like square root of 11. Oh, it's approximate because we don't know what exactly is. So square root of 11, if I do that, if I type square root of 11 in my calculator, it's going to give me 3.316624 and so forth. So with numbers like this, we don't know. All of these are irrational because we don't know, because it's giving me these long decimals that doesn't terminate, so it doesn't stop like this decimal here, and it doesn't repeat like this decimal here and here. Like for instance, another example of a terminating decimal is like 4.5. That's what it's rational because it stops. 1.2, 3.6. These are terminating decimals because they stop. But some long decimal that just goes on, like if I make up a number like 50.870194.7, you see there's no pattern to this. We don't know what's going to happen. So that's irrational. So you're going to need to know how to classify the difference between irrational numbers and rational numbers. You don't necessarily need to know all this. I mean, it's good that we do know, but you need to know the difference between a rational number and an irrational number. So that's the first part of this lesson. The reason we need to know that is because we need to learn how to approximate. All right? And keep those notes by, because we need to know how to approximate. So what I want you to do is make a number line on your paper from 0 to 13. Let's do that. Oh, I dropped my marker. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so mine only goes to 12. Okay, so if you can get yours to 13, great. But mine is going to 12. Pick up my marker. Okay. All right. So we got this number line. You know your numbers. Okay. So now we're going to make a square root number line, sort of. So I want to rewrite these numbers as square roots. So 0 is square root of 0, right? Because 0 times 0 is 0. 1 would be the square root of 1, right? Because 1 times 1. But what I have to take the square root of which number to get to? 4. Because 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So the square root of 4 is 2. 3 times 3 is 9. So the square root of 9 is 3. 4 times 4, 16. And you finish it, right? 5 times 5 is 25. 36. 49. 64. 81. 100. 121. 144. And if yours go all the way to 13, 169. Square root of 169. Okay. So you're going to have to learn how to approximate. So we need to memorize these square roots. I need you to know that the square root of 144 is 12. You need to know that the square root of 121 is 11. You need to know that the square root of 49 is 7, and so forth. Because this is how we approximate. Stay with me. Okay. What if a question on the quiz is, what is the square root of 40? What's the square root of 50? They're gonna ask you, is the square root of 50? First, they're gonna ask you, is the square root of 50 rational or irrational? Now, 0, 1, 0, 1, 2, 3, all the 1 through 12, so you know they're rational because they're here, right? They are whole numbers, and square root of 0 is 0. So if 0 is rational, square root of 0 is rational. If 1 is rational, square root of 1 is rational. If 2 is rational, square root of 4 is rational. If 3 is rational, square root of 9 is rational. If 4 is rational, square root of 16 is rational, and so forth. Right? So all of these numbers that's in blue, they're all rational. But is square root of 50 up here? No. So if it's not up here, that means it's not rational. So first of all, the square root of 50 is irrational. So we're going to write that. We can say that first. So square root of 50 is irrational. Because it's good to know, even if they don't ask me this question, it's good for me to know. So square root of 50 is irrational. Now, I need to approximate what is the square root of 50. Now, if the square root of 50, you got to figure out between which two whole numbers is the square root of 50. Well, this is square root of 0. This is square root of 16, square root of 36, square root of 49, square root of 64. 50 is in between 49 and 64, right? So the square root of 50 is between 7 and 8. So I know that the answer to this is going to be approximately 7 point something. Right? Because it's greater than the square root of 49, but it's less than the square root of 64. Now you got to be able to approximate. Would you say that it's 7.5? Like, is 50 halfway between 49 and 64? Probably not. 50 is really, really close to 49, right? And you got to start to think about how many numbers are between 49 and 64. So you got 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. So there's 15 numbers there. So you're like cutting this up. So it's not even going to be 7.1 because it's not even 7.1 yet. So you can approximate it to be like 7.05, right? So we're just guessing. And even if you approximate it to be 7.1, you still will be right? You're just approximating. You're just taking the best guess. So I would go a little deeper and say 7.05. But as 8th graders, if you can at least understand that it will be 7.1 versus 7.5, you're good to go. Because 7.1 is not far from 7.05. It's only off by 0.05. So let's check our calculators. Let's see what the square root of 50 really is. Because we're approximating. We're not going to be exactly correct. So the square root of 50 is 7.07. So we're close, but we're off by 0.02, which is really, really close. So we're good. We're not going to be exact. We're approximating. We're not equaling, right? So make sure you pay attention to that. So let's approximate another one. So let's say we did the square root of 16. So the square root of 16. Is it rational or irrational? Is it up here? The square root of 16 is 4 because 4 times 4 is 16. So the square root of 16 is really equal to 4. Therefore, it is rational. And we're done with that. Okay? So let's do something harder. Let's do the square root of 110. Let's see. So the square root of 110. I can't write it. Okay, there we go. The square root of 110. Is it up here? No, we got square root of 100. Then it goes to 121. 110 is in between these two numbers, so I already know that it's irrational. That means it cannot be written as a fraction because we can write all these numbers up here as a fraction. For instance, the square root of 64 is 8. I can write 8 as a fraction by saying 8 over 1. Right? We learned that when we were doing slope. So all of these numbers can be written as a fraction. Let's go. Okay, let's finish this. So square root of 110 is in between these two numbers. So we know that it's approximately what? 10 point something. So let's see if we can figure this out. So between 100 and 121 is 21 numbers, right? And 110 is that closer to 100 or is it closer to 121? It's a little bit closer to 100, but it's kind of like right in the middle. So a good approximation would probably be like 10.5, right? Or we can say, if we want to be really, really slick, we can say 10.47. If we want to be really, really slick. But for an 8th grader, a good approximation would be 10.5. Okay? So let's check. Or we can say 10.45. Let's see what the calculator says. And you won't be able to use a calculator on this part of the test. So if we take a test, but you still need to know what you're doing. So the square root of 110 is 10.48. You see, we were really, really close. And even if we put 10.5, we're still close because it's 10.48. Okay? So I need you all to learn how to approximate. Hopefully you got that. And I'm going to put some links in the description below. It's my first YouTube video. Bear with me. I'm going to put some links in the description below for you all to practice. And also you have this workbook. So let's work a couple of these together. Sorry. I need to get my pencil. Okay. So here we got section A. It says Introduction to Irrational Numbers. You already know what an irrational number is. So it says determine whether each number is a perfect square. All of these numbers up here, you already know what a perfect square is, or a perfect square. Because 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. All of these are perfect squares. Okay? Determine whether each number is a perfect square. If it is a perfect square, write the number as a product of its two factors. Okay? So for instance, if they gave me square root of 9, square root of 9, yes, it's a perfect square. And the product of its two factors, 3 times 3. So 3 times 3. But we're going to go a step further and write it with an exponent for me. So let's look at number 1. Because I'm going to do number 1 with you. Determine whether each number is a perfect square. If it is a perfect square, write the number as a product of its two factors. So let's look at, so this is A, section A, number 1. So we have 20. Now 20, the square root of 20. Is that on here? Is the square root of 20 on here? Is it a perfect square? No, square root of 16 is a perfect square. Square root of 25 is, the square root of 20 is somewhere between this. So we know this is in irrational numbers. So square root of 20 is, no, not a perfect square. So we say no, not a perfect square. Therefore, it is irrational. And I want us to go ahead, let's approximate it. Square root of 20. It's between which two numbers? 16 and 25. 20 is about halfway between 16 and 25. It's a little bit closer to 16, but barely, so we can approximate to be 4.5 or 4.45 like we did last time. So square root of 20 is approximately 4.5 or 4.45. Okay? And we cannot write it as a product of its two factors because it's not rational. So let's move on to number 2. Number 2 is 36. So we change it to a square root of 36. Is that on here? Yes, it is. Square root of 36 is 6. So yes, it's a perfect square. Yes, it is a perfect. Therefore, it is rational. And as a product of its two factors, we're going to say square root of 36. We don't have to approximate. It's equal to, because it's rational, 6 times 6. And we can say that's 6 squared. That's how I want you to do these 1 through 8. Okay? So that's part A. You're going to do the rest. And so you only got 6 more to do. B, determine the square root for each perfect square. You can do that. I don't need to help you with that. Because I suppose. Let's do 1 for B. Number 1. Square root of 64. Determine the square root for each perfect square. So they're telling you that all of these are perfect square. So what's the square root of 64? Do I have to approximate or do I have to say equal? Do I put approximately or equal? Equal. Because it's a perfect square and it's equal to 8. Oh man, I was wrong. For number 2, take off the square root. So 36, 6 times 6. 6 squared is 36. And for C, approximate each square root to the nearest 10th. The square root of 130 for number 1 is not a perfect square. Let me go back to our chart. It's not a perfect square, but it is between 11 and 12. So it is approximately 130. It's about 9 spaces from 121 and 14 spaces from 12. So it's not quite at the halfway mark. So I will put it probably at 11.35 or 37 or 4, even 4, right? So it will be 11.37. Right, approximately, or you could have said 11.36. Let's check to see what we are. See if we got it right. So 130, take the square root of that. It's 11.4. See, we were close. I was trying to be extra. So, or 11.4. approximately. Let's keep going. And also, because I made an error, make sure for number 2 up here under A, you don't put the square root, because the square root of 36 is 6. But 36 is 6 times 6, 6 squared. But the square root of 36 is 6 times 6. So if it's rational, keep it as don't put it under the square root. If it's irrational, you can put it under the square root and approximate it. For C, you're approximating again, and for D, you're classifying each number as rational or irrational. So, for instance, 0. 0 is irrational or irrational. We need to look when you pull our notes back, and we need to look, is 0 on the rational side or is it on the irrational side? Then -5 is number 2. Is it rational or is it irrational? Can it be written as a fraction? Because rational numbers can be written as a fraction. Irrational numbers cannot be written as a fraction. Also, it is non-terminating and non-repeating. Okay, so let's look at the next page. It says graphing real numbers on a number line. Plot a point on a number line to represent each given number. Okay, so we have negative 2.3 and negative 2.2. You need to approximate negative 2.257. So if this is negative 2.2 and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it's figure out what it's going by. I don't want to tell you all, but I want you to try to figure this out on your own. So make sure you plot these numbers. Really, really think. Figure this out. I know you don't like fractions. Think about 1/9. What does that mean? What is it as a decimal? And figure out where it would be. Think about what you know about the square root of 4. And then put the negative on it. Represent pi on the number line. We just talked. You already know what pi is approximately. So figure out what that would be on here. Try to be as close as possible. Represent 4, 7th, 8th on the number line. You already know about 4, so this is between 4 and 5. So 7, 8th. Think about where that would be on the number line. And then the negative square root of 28. Think about where that will be. You can use this number line to help you figure out where negative square root of 28 would be. Because you know our negatives are this, but the opposite going the other way, right? So think about that. You already know how to do this. Okay. So order rational numbers. So now you're ordering these from least to greatest. Okay. So we got 92%. We should know how to change 92% to a decimal. Then we have pi. We have negative square root of 2, and we have negative 3, 8, and 9. 3 and 8 ninths. You cannot order these right now because they're not the same. So you need to change all these numbers to a decimal. All numbers can be changed to a decimal, right? All of these numbers can be changed to a decimal, but they all can't be changed to a fraction. See, when I had pi, I can't change it to a fraction. This is the decimal. This is the decimal for square root of 2. Negative 1/2, I know I can make that into a decimal. Negative 0.5. Square root of 4, I can make that into a decimal because square root of 4 is really 2 into 2.0. 2/3, I can make that into a decimal. We're going to be repeating, right? So it's equal to 0.6666 repeating. So order these numbers, do the best that you can from least to greatest. Okay. And that's all for the real number system. I will drop some links below. So I need you all to complete page 109 through 111. You should have already completed up to page 108. And now we're on page 109 through 111. I will give you a few days to do this. Okay? But I will be checking this when we get back to school. Thank you.